Hey there everybody, welcome to this video. Today I want to go over a paper that a partner and I have worked on publishing on GitHub. It is by no means a completed product. It's still something that we're working on, but this is the main idea over here. This is the conjecture that we've come up with. And just to be a little bit more clear, this is a conjecture that he has come up with in number theory, especially or specifically in the topic of prime numbers. So the conjecture itself is that any prime number that is greater than 3 can be represented as the average of at least two distinct prime numbers. So two unique prime numbers can be added together and then divided by the number of numbers to get any prime number greater than 3. So let me make that a bit clearer with an example. Let's take 7. 7 is a prime number, and it's greater than 3, which satisfies that condition that I set up earlier. So this number 7, if we wanted to represent it as the average of two distinct prime numbers, we could do it very easily. So if I just multiply this by 2, which is the number of prime numbers we want to represent it as the average of, we get 14. And basically what we need to do is we need to find two different prime numbers that add up to 14, which is very easy. Given it's a small number, we can take 11 and we can take 3. Both of these numbers are prime numbers, and adding them up gives us 14, which is actually the same as that equation we set up earlier. So P being 7 is equal to P1 being 11 plus P2 being 3 over this 2 over here. So when we add these two numbers up, and then when we divide by this, we get 7, as you'll see here. And this relationship, of course, can be done with more than two numbers. If we wanted to, we could also represent 7 in terms of 3 different numbers or more. So let's try 3 as an example. We just need to find 3 numbers. They may not be distinct like in the case of 2, but we need to find 3 numbers that are primes that add up to 21. One of them could be 11. Another one, 5, and we can take 5 again. So these 3 numbers add up to 21. And when you divide them by 3, you get 7. And just to further test this idea with some bigger numbers that would be kind of difficult, if not impractical to manually calculate, I've created some code to automate most of the procedure. So in this code, you have the opportunity, or in this graphical user interface, you have the opportunity to either generate a random prime number or enter one in yourself. So let's first try this with a provided prime number we specify. So I'm going to go with, let's say 13. It's pretty small. Now, we found that 3 and 23, these two prime numbers, actually give 13 as an average when you sum them up and divide them by 2. And here's the proof. Just a quick little something. So the number of discovered primes times the specified prime, 2 times 13, that gives you 26. And the sum of the 2 discovered primes also gives you 26. So the left side equals right side, meaning, yeah, there it is. It's proved for you. And we can also, put in something bigger, the random prime. Let's go with 24 digits. Okay. Here is a 24-digit prime number that was randomly generated, and here are 2 discovered primes that, if added up and divided by 2, will give us this prime number. Just as how we saw the proof for 13, the proof for this relationship is here as well. this whatever number starting with 1685 is equal to this whatever number starting with 1685 and ending with 306. So there you have it. I hope this video was informative. Bye.